if you have worked with relational databases, whenever you do like a schema change, for example, it's sometimes a big deal. I've in my past worked with RDBMS, and sometimes you'll have to take the system down to even do changes to your tables and things like that. With JSON, the schema is more flexible, so you could change schema without any downtime. Also, it provides for a quicker application design as well. So those are the 4 key pillars we have, and it's worth mentioning again: the scalability, performance, high availability, and the flexible data model. So that's the 4 pillars based on which the enterprise product is built. So what are the core features? We offer built-in clustering. And in Couchbase, a very important point to note is that all nodes are equal. Not all NoSQL systems are that way. You have other NoSQL systems where there are special nodes, master nodes, things like that, and you'll have to manage each of them separately. With Couchbase, every node is the same. If a node goes down, it's not a big deal. You can replace it. It's all the same. We don't have any special nodes in the cluster, so it's not like there is a single point of failure. Data replication. We provide data replication within the cluster. You could either do an auto failover, which we support, or you could do a manual failover as well. Both modes are supported. And like I mentioned, there is 0 downtime for maintenance, so the cluster is always on. One of the very, very key features in Couchbase, and I'll see this in other slides as well, is that we provide a built-in managed cache. If you saw the Viber presentation, earlier they used to have MongoDB, but they also had Redis for caching. And one of the key advantages in Couchbase is you don't need a separate caching layer. The caching layer is built into the product. If you look at the origin of Couchbase, it came from Membase and Couch1. Membase was a caching related product based on Memcached and event-oriented database later. But they merged together, and now you have the caching layer built into the database. So you have layer consolidation, which is really efficient, makes it really simple. You don't need to specifically program for caching and things like that. Couchbase is also an append-only storage layer. What we mean by that is when you write to it, we append. We don't actually go and do in-place modifications at that point in time. We actually append. And the reason for that is we want to provide really, really high write throughputs. So, and for systems which need to provide such kind of thing, the architecture has to be an append only. And of course, that means we need to compact things later, and therefore we do provide online compaction, which is automated these days. So the system will automatically compact over a period of time. Another key thing, and you will see this during the demo, is we have monitoring and admin user interface. This is a key feature for us. Not every product out there in NoSQL has a very nice monitoring user interface. And a lot of the customers that we have talked to sometimes come back and tell us, hey, you talk a lot about your server product, you talk a lot about the server features, but we really like your monitoring user interface. We really like the UI, we see the graphs, we see all the, how the operations per second changes, how the buckets are laid out, things like that, and it really helps them. And last but not the least, the server is a very important part, but your applications are going to use languages like Java or C#, Python, whatever it is. And we provide SDKs for a variety of languages. For almost all the key languages, Java, C#, C programming, Python. I think recently we also added Node.js SDKs. So if you go to our website, you'll find a whole bunch of SDKs. And so any popular programming language, we support it. And we will continue to add to the list as we go. This is our previous releases. Very quickly, I'll go over this and so that I can cover the newer release next. In 2.1 and 2.2, we provide a multi-threaded persistence engine. Previously, you could have only a few threads, for example, in the engine. Now we actually allow you to configure a multiple thread for each bucket in the engine, so you can have a much more efficient read and write. Optimistic XDCR. XDCR stands for Cross Data Center Replication, which is one of the disaster recovery schemes, and I'll talk about it. Optimistic XDCR is basically allowing you to send packets over to the other cluster without having to check first if it needs to be sent, so we just provide better latency. We also provide a cluster health check tool we introduced. Host name management is one of the highly asked features where people wanted a more meaningful name instead of just IP addresses. When the cluster rebalances, we show rebalance progress indicator. I'm just going over this quickly because I'll cover more details later. I just wanted to give a brief introduction to this. And we also have a new protocol for XDCR, which is across data center, which is just much faster. Read-only admin, a lot of people wanted this, where today in the admin UI, earlier it used to be that you could make changes, and people wanted to provide read-only user interfaces so more people can access what's going on in the system, but they don't accidentally change things in the system. And we also provided, like I mentioned, automated and optimized purge management as well as compaction. And CB recovery is a feature which allows you to recover if there is any problems in your cluster. You could point to a remote cluster which has the right data, and it can recover certain partitions. So, more importantly, I'm very, very excited to announce that very soon we are releasing Couchbase 2.5. I would expect it probably in a week or two maximum. And if you go online, you'd probably be able to register in the next week for a webinar, which provides a lot more detailed information on these features, which we'll be announcing in a little bit of time. And there'll be a detailed webinar going over all the features, showing you a demonstration of all these things. So I encourage you to go to our website maybe next week and sign up for that webinar. It's a 2.5 release, which means it's a minor release. But even then, we are announcing some really key significant features. In the availability and reliability area, we are introducing a very important feature called rack awareness, which a lot of our enterprise customers would use. And I think Viber, for example, was also interested in that, they were mentioning. And I will go over this feature a little bit more. I'll explain this in a later slide. But it allows you to essentially have much higher availability by segregating your clusters into groups. And so if you have multiple racks in your system, data center, if an entire rack goes down, you still have replicas available on another rack. Security is a key feature. Again, a lot of enterprises want us to continue to invest in the security area, and we are continuing to do that. Between two data centers, we have the cross data center replication, and we are adding encryption to the data when it's sent over between the two data centers. And that's a very, very key requirement for large enterprises that we're dealing with, who in the IT departments want to make sure it's secure, the communication. We also have ease of administration feature in terms of better client connection management. So you no longer have all clients needing to connect to our 8091 port, which I will explain in the next slide. And what that allows you is essentially higher concurrency, higher connections, as well as more efficient data transfer between the client and the server. These are again coming out in 2.5. I'm very, very excited to announce that. And you will have more details coming very shortly if you register for the webinar on our online website. A brief introduction to the Couchbase server architecture. Every node in Couchbase, like I said, is very similar, and every node has these two key components, the data manager and the cluster manager. And let's peel under the covers to see what is here. So the data manager essentially has the multi-threaded persistence engine that we talked about, which actually stores the data. It also, like I mentioned, has the object managed cache. So it's built in to Couchbase, the cache. And it also has the query engine, which is where you query the data using views and things like that. The cluster manager essentially manages things like replication, rebalancing, sharding, things like that. It also has the REST management APIs as well as the web user interface is pretty much done by the cluster manager. And between these two components, data manager and cluster manager, every node has them, and they're very similar. And that is why if a node goes down, you'd be able to bring in another node, and it's the same identical architecture. And we have certain ports that Couchbase uses. 8091 is the admin console, and 11.2.10 and 11.2.11, they are the data access ports. There are 2 ports because depending on your client, one of them is a legacy client, and one of them is a smart client, which is a more updated client, which uses a different port. And when I explain the basic operation, you'll see how it functions. I'll go on to the Couchbase operation. One of the key concepts in Couchbase is the auto sharding. And what is auto sharding is essentially it makes sure your data is automatically spread out evenly between the nodes in the cluster. And we use something called as vbuckets, and I'll go to the next diagram, you'll see that. So this is an animation. What's happening here is we want to make sure, and this is a key concept to understand in Couchbase. If you've read any documentation, you would have seen this. And what this is when a data comes in, it gets hashed using a key, and it gets assigned to a vbucket, which is called a virtual bucket. It's essentially a partition. Think of a virtual bucket as a partition. You have physical servers. In this case, we have servers A, B, and C. And each of these keys get mapped to a partition, and the partition is actually tied into a physical server. Why do we do that? The idea is that we want to be able to rebalance easily. You want to be able to know where your key belongs in a very consistent way. So once it's hashed, it always belongs to the same vbucket. When data moves, it's only the vbuckets that get moved between the physical servers, but the key is always mapped consistently to a vbucket. And when you add new nodes, it allows you to basically take a partition and move it to the new node. So now if you see, let me actually do this. Again, you'll see here that initially there is A, B, and C. And the data is distributed between them. And when you add a new node, which is D, towards the right side, and you'll see that now the data, the partitions get moved, and you'll find that the data is uniformly distributed. Using this, basically, we don't have any hotspots. The data is uniformly distributed, and therefore your workload is kind of uniformly distributed across the cluster. And this is a key concept in architecture that we have. And the cluster map is actually a map that maintains where the partitions map to the physical servers. So, and you'll see why the cluster map is important. When the clients connect, they actually use the cluster map. Any question on this? Good question. So the question is, how many logical partitions are there? So for every bucket, we have 1024 partitions. That's the default number of partitions. Now, you could change it, but you would change it only in certain specific cases based on your workload. But the default usually works for most people, which is 1024 partitions. Uh, 50 nodes per cluster? Right. So the nodes are basically the physical servers, right? So the reason sometimes we say, I think Vaibhav mentioned 50 nodes, is because there's aspects of manageability that's involved when you have a very large cluster. So sometimes when you really had to have a much, much larger cluster, we recommend sometimes having 2 separate clusters. So split your cluster into 2 separate clusters. Essentially, it's more for manageability as well as things like when there's a point at which if your cluster is extremely large, then it becomes a little more complex for you to kind of manage the entire cluster. So for manageability cases, we actually have larger clusters, but we just split it into 2 clusters and then treat it as a one logical cluster. So let's look at some of the operations. A single node Couchbase, right. So this is one node in a Couchbase. I'm using one node so that you understand the basic fundamental operation of Couchbase. You have your disk, you have the managed cache, and to the far end you see the disk queue, and this is the replication queue. What is the disk queue? So when you write something, you basically would write it into the cache. And in Couchbase, a write is basically asynchronous. When you write it into the cache, you pretty much have written it. Then it moves from the cache to the disk queue, and then eventually moves into the disk for persistence. The replication queue is basically when you have other nodes in your cluster for high availability, you want to make sure the data gets replicated to the other nodes, maybe one replica or two replica depending on how you configure. So it also writes the data into the replication queue and then eventually moves it to the other nodes as well. So you have in this case the app server, which is basically our client. When you say client here to the server, even the application server is a client. So the application server has a document, and when the document comes in, it gets written to the managed cache, and then it goes to the disk queue and the replication queue, and from the disk queue it gets written to the disk, and from the replication queue it gets propagated to the other nodes. So that is essentially how a basic write operation works. So yes, so once it's in the cache, the client will get the acknowledgement that the write is successful. Now, there are parameters on the client side that you can say at a per operation level that you only want the client to get an acknowledgement if it is maybe replicated to at least one node. Or you only want to get the acknowledgement if it is persisted to disk, for example. So there are ways by which you can do that, but on a per operation level. You don't want to overdo that because it naturally slows down your system. So the update operation essentially is you get the document, it gets updated in the cache again, and then eventually again the same thing happens. The update goes to the disk queue, to the disk, and to the replication queue. Very similar. The update happens first in the cache. When you update the document first gets updated in the cache. And then actually, what happens is it'll get appended in the disk, and eventually we will compact it to keep the latest copy. So it doesn't actually go and physically replace in place. It actually just writes the newest update. And then eventually it'll delete the old. The system will automatically compact. Say that again? So the question is, how do you handle fragmentation? And that is why you have the compaction process that runs, which periodically will go in and remove the things, as well as it will also do the defragmentation at that point in time. So there is a process which takes care of that. So what happens when a read happens? You say get document and it gets read from the cache. And that's one of the main advantages in Couchbase is using the cache is you want to provide really, really fast access. And the cache provides that. Of course, we will, in some cases you may have a miss and we'll see what happens. So what is cache ejection? So you keep writing to the cache, the documents eventually get onto the disk, but at some point in time the cache memory may be full. So then what happens is, in this case, the document 1 got ejected, and it's now the document 1 is only available on disk. It's not available in the cache. So what happens in this case if a read comes in for the document? So here's a cache miss. So there is a read that comes in for document. It's not there in the cache. What happens is now the system has to read it up from the disk, put it in the cache, and then it serves a request from the cache. But it always serves the request from the cache. So even if it reads from the disk, it puts it in the cache and then serves it. But now the document is in the cache, so if another read comes in for that, you can serve it faster. We have this not recently used algorithm. So yeah. So the basic operation is, you'll see that in Couchbase, the documents are evenly distributed across the servers. And here we're seeing the actives, but there's also replica. So in this particular case, for example, I'm showing document 9, that it has a replica on server 3. And each server stores both active as well as replica documents. But only one server has an active copy of a document. So there's a client library, and there is a cluster map in the client library in the Smart app. And it provides information on where the document is. So if the read or write comes in, it directly goes to the particular server, and so it's smart enough to figure out where to go. So that's how the basic operation works. What happens if you want to add nodes to your system? So if you want to add nodes to the cluster, essentially, in this case, firstly, you can add multiple nodes. So you have 2 nodes that you can add with 1 click. And the documents are automatically rebalanced across the cluster. So both the replicas as well as the actives, they get evenly distributed. And the cluster maps are now updated as well. So if any new request comes in, so they know where to go for accessing the documents. And I'll actually, the reason I'm going a little faster is I just want to show you the actual system where we can add nodes, for example. What happens in the case of a failover? So here you have, unfortunately, things do, app servers are accessing the documents, failure happens, that's life, it happens. So request to the server 3 is now failed. Now the system will detect that the server has failed. It promotes the replicas to active, and that's why you have the replicas. So you saw the replicas getting promoted to the active, and it'll update the cluster map saying, now here's where the new actives are. And now the request can go to the appropriate server, and you can fix your server 3 and eventually bring it back on. So that's how the failover works. Sure. Sure. You can do that. This is the add nodes. Okay. So failover is essentially the app servers are now accessing documents, let's say on server 3, and server 3 goes down because of a failure happens. Now, what happens is you have, for example, doc 1, doc 3, etc. on server 3. There are replica copies of it available on other nodes. Now, when the cluster detects this failure, it will promote these replicas into active on other nodes. And now it will also update the cluster map saying where the actual actives are. So now any new requests that come in will start automatically going to the right server. So that's how a failover actually works. That's right. So there is a communication between the server to the client, which will update the cluster map on the client. Now, there are 2 ways the cluster map can be updated. The client can request a cluster map from the server, but the server can also push the cluster map back to the client. Right. So these clients are all the smart clients, and we generally recommend people to use the smart clients. Now, people who are using from many years ago, they used to have these legacy clients, and they are not smart clients essentially, but they can still access the things. But it's just that the automatic updates of cluster map and things like that happen for the smart clients. And most of our customers have now moved on to the smart clients, because for the last, at least a year or 2, we've been having the smart clients. Yes, 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 yes. Mm-hmm. So essentially, the first question is, yes, it could be a hardware failure. There is a heartbeat that the system tracks. So if it loses the heartbeat, it's essentially saying that that node is probably failed. And we have a 30-second automatic failover time frame. So it takes 30 seconds for it to detect, and then immediately promotes the replicas and sends the cluster map updates and things like that. And the reason for the 30-second is because you don't want a false failover. A failover is an operation, so sometimes there may be a temporary glitch or something like that, so you don't want it to immediately fail over, so you want at least 30 seconds to make sure that it's not responding. So in those 30 seconds, any request that goes to the server 3, for example, it'll not work. But the client can retry that connection. So that's essentially what happens. No, it does not read data from the replica. It does not get the data. Replica reads are a special case. You could do replica reads, but you could sometimes have stale data if you do replica reads. By default, it doesn't do replica reads. By default, if it goes to a server which is failing, the client will have to retry the connection, basically, and eventually get routed to the right place. So, you had a question? Say that again? The heartbeat? Who manages it? So one of the nodes, for example, is an orchestrator, and the orchestrator would actually sense if the heartbeats are coming in or not. So it is not essentially special in that sense that if the orchestrator goes down, there's automatically a new orchestrator that gets selected. So in that sense, if the orchestrator goes down, a new orchestrator will be elected, and that orchestrator will be able to manage it. So we do handle the case if the orchestrator node goes down. So it's not a single point. So yes. No, the key architecture in Couchbase is there's only one active at any given point in time, and that's how we, and that is how we do essentially immediate data consistency. In other systems, sometimes there is more than one active, in which case you'll have eventual consistency of your data. But Couchbase actually provides immediate consistency of data, so for writes. Say that again? It's actually active, and I would call it replicas. So yeah. Let's do a quick demo just to show the system. All right. Let's do a quick demo of some things. So here I have essentially a cluster which is 4 nodes I've set up. And you can see that there is also data that's coming on the system. There's workload. I've applied a workload. So you can see the operations per second. Now it's like around 20,000 operations per second going on in the cluster. And let me see how easy it is to add, let's say, 2 nodes to this cluster. So you have a 4 node, and I have other nodes set up, which is not part of the cluster. So what you do here is you go and say, it's as simple as saying add server. I give the IP address, enter the password for the node. It's very simple, actually. It says adding a server means all data on that server will be removed. So this is a warning. We'll say, OK, add server. And as you can see, it still says 4 nodes. And the reason is it's pending rebalance. And also the reason is we can add more than one server at the same time before we do a rebalance. It's important because it's not like each time you add a node, you have to rebalance. So we can do it in one shot. So let me go ahead and add one more server. So I'll make it 6-node cluster. So I'll do the add server, add this. Okay, so now there are 2 things pending rebalance, and here are the nodes we added. So we can just say rebalance. And you can see here the rebalance operation is going on, and those nodes are now getting added as part of the cluster. And if you actually go to the expand one of these things, you'll actually see here that the number of keys being transferred, total number of the active buckets and replica buckets, and it's changing, and it's pretty cool, actually. And if you actually go to the data buckets, I can actually show you So you can see here, this is all, and the key thing to note here is, this is all happening while the workload is happening on the system. So you can see there's a number of sets happening, certain number of gets happening. So while the operations are going on in your system, your rebalance is also happening at the same point in time. And you can see here, there's indicators, and this is what I mentioned, there's rebalance indicators, which is showing that, okay, it's now 40% complete, 50% complete, and you'll actually have this going on. In the interest of time, I'll let the rebalance go on. I'll go talk about a few other things while it's happening. So, sure. Mm-hmm. What protection? So essentially, for one of the key things in Couchbase is sizing. When you actually deploy something in production, we actually do a sizing exercise to make sure that the resources are well allocated. And it's a process that we work with, for example, customers like Viber. When they actually go for deployment, they work with Couchbase to say, kind of estimated resources, things like that, what is the projections we have, and we size the CPUs and memory and everything in the system to account for that. And that's essentially the main protection that we offer, is a well-sized cluster performs actually quite well, actually. If you undersize your cluster, yes, you could run into some of these issues that you talk about. So, sure. No, that's what I was showing you. If you do, it doesn't really, well, there is always a slight impact, but it doesn't hugely affect it. So there was this 20,000 operations per second going on while I actually did the rebalance. And so it is okay. It knows how to handle that. So let's quickly look at the indexing and querying. Essentially, we offer views on the system. And essentially, views are basically materialized views on your JSON documents. So you could, for example, the key value provides the fastest access, but in some cases, you want to access based on secondary indexes, let's say on email address or zip code or things like that. So essentially, we build indexes, and those are basically what we call as materialized views. And it's important to understand the views are eventually consistent. What I mean by that is, so let's see here. You have data, and it's building the indexes, but the indexes are on disk. So if you have data updates that happen, the data is immediately consistent, like I mentioned in Couchbase, but it could take a few seconds, maybe less than a second actually, for the indexes to get updated. And so if you have a secondary query request that's going on to an index, there may be some cases where the data is more updated than the index, but we choose that because you don't want to penalize the writes, essentially, so we always keep the data very consistent. But we're actually coming up with newer features in next releases which improve the latency here, so it's more real-time, the index updates and the data as well. But you do have indexing, and you do have querying capabilities in Couchbase. And in the evening, I will be presenting another session, which is more a future-looking one on Nickel, which is our new query language that we are developing. Also briefly wanted to touch base on XDCR, which is our cross-data center replication. So you can actually replicate data between two clusters. It can be spread across geographical distances. It provides disaster recovery, so we are very strong in high availability as well as disaster recovery. You could actually importantly do active-active, so it's not just active and replica in this case. So it can be a hot standby, or it can be a master-master, where both clusters can get updates and they can share data. So that's possible as well. You can, so yes, it's possible. Yes, it's possible. So I think your question is, can I have geolocality, right, to data? Yes, so this is one of the other topologies that we offer in XDCR, and some customers use that as well, where you could have a data center in China, you could have a data center in North America, you can have a data center in EMEA, and you could have people in those regions going to the closer geographical data center for faster access. Yes, it is in the client. Yes, 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 that's correct. Say that again? Yes. Yes. So we do have basic conflict resolution built in. It works based on sequence IDs and a bunch of things like revision and things like that. It is a little bit basic right now, to be very honest. But we have in our roadmap other ways of doing conflict resolution, as well as allowing the application to do their own conflict resolution, because each app sometimes want to do conflict resolution in different ways. And we want to be able to plug in that kind of conflict resolution. Today you cannot. Today the Couchbase Server does its own conflict resolution, which is a little more basic. But going forward, it's one of those things that we are planning to add. How much time do we have? Can I wrap up? Okay. So let me just quickly see if there's something that I want to cover before I end. One of the things I do want to mention is Nickel, which is our new query language. And this is actually a very, very exciting thing that we are planning to announce. And we would probably have the beta release sometime later this year, and maybe the GA maybe towards end of the year. But this is, a lot of customers have been asking for this. It's a very simple SQL-like query language. So you can write, for example, select blah, blah, blah from something, where something equals something, and it's very easy. We have a separate presentation on Nickel this evening, so if any of you are interested in that, I really encourage you to attend that, and I'll go over a little bit of what we are. This is brand new. It's not released, but I'll give you a preview on what it is. So.